Welcome to class. I will say pause during this video, so please pause and give the students the opportunity to write something down or to think about it or reflect. First of all, students, you should have gone to the back of the room to pick up your notes. If you have not done so at this time, please do so. Again, you should know this by now, as we're almost at the end of school. So first of all, please open up your composition notebook to page 1. On page 1, you will find your table of contents. Da-da. Today we are working on pages 154 and 155. Today is May 9th, and we are getting ready for STAAR. Right now, I am currently in the LGI, getting ready for the STAAR pull-out to prepare you for STAAR. So, first of all, tape your notes onto page 155, or you may tape it at the end of class if that is what you prefer. Now you are going to do this warm-up on page 154, this number routine. So alike and different. Name two things alike and two things differently about these numbers. We have 1 and 5 hundredths, 21 over 20, 105%. So in your notebook, some students, what they do is they make a chart that says alike and different. They make a little T-chart, and then they write down the differences or the similarities between these numbers. So please pause at this time. Students, write this on page 154. Welcome back. So hopefully you had time to write something down. So I would like you actually to pause again, and I would like you to call on different students, and so they can share what they think makes these numbers alike and different. So please call on different students just so they can reflect on their thought process. Pause. Welcome back. So we have three numbers right here. So these are the answers I was looking for. We have 1 and 500, 21, 20, and 105%. These are all called rational numbers. If you forgot, take out your green study guide. It's actually on the very, very first page. Rational numbers are any numbers that can be written in ratio form or fraction form or decimal form, such as all of these. This actually can be written in a fraction form, 105 out of 100, because the percent means out of 100. Next thing is they're actually all equivalent. They're actually all the same number. Before you say, yes it is. Let's look at this fraction right here. How do you build 21/20th to a percent of out of 100? What is the scale factor here? It is times 5. So 21 times 5 is 105 hundredths, which is the same as saying this, 1 and 5 hundredths and 105%. How are they different? Well, first of all, this is in decimal form, fraction form, percent form. So, and I'm sure there are other answers. I cannot remember any right now. All right, so now take out your previous homework. It was a white packet that you were given. This is your homework um, that was given to prepare you for STAAR. All of these questions are sample questions that you may see on the upcoming test. So these are to jog your memory. So Unit 2 was about proportion, measurement, converting measurement, and over percent. So number 1. So the answer to number 1 is 39 white. So there are 10 questions here. Each question is pretty much worth 10 points each. So the answer is 39 white. You might say, but why? How do you build 5 cars to 65 cars? The scale factor is times 13. 3 times 13 is 39 white. Number 2, 3 out of 7 students wear jeans. How do you build 7 students to 560 students? The scale factor is times 80. That's why the answer is 240 jeans. Number 3, Laura has 4 red, 6 blue. Which statement is true? Oh, they're comparing the blue to the red. So we need to switch this around. 6 blue, 4 red. This simplified to 3/2. So the number of blue pencils Laura has is 1.5 times the number of red pencils. Number 4, What was the price per pound that Mrs. Gomez paid for the ground beef? So she spent $18 for 8 pounds. You can simplify that to $9 for 4 pounds, $4.50 for 2 pounds, $2.25 for every 1 pound. So which of these does circle the prices below that do not represent the same price? Um, so I so which one does not equal to 225 per pound? This one and this one. The uh, the last two. Shade the following percent to show the indicated percent. 1 out of 8. How do you build it to 100%? This is where some kids get wrong. So to build it to 100%, you can divide 800 divided by 8. Can 8 go into 100? One time. Can 8 go in 20? Two times. How do you get rid of this remainder? Annex is 0. That's where you get times 12.5. So the scale factor is times 12.5 or 12.5 hundredths or 12.5%. Or another way to do it is how do you turn an 8 to a 1? Divide by 8, divide by 8. That's where I got that one from. So next one, 20%. 2 out of 10 is the same as saying 20%. Number 7, draw a percent bar to show 30%. What I did is I cut it into 10 equal parts and shaded 3 out of 10, which is the same thing as saying 30%. Number 8, the answer is 63 white or blue. First of all, you're supposed to count the number of marbles in a box, the total number of marbles in a box, which are 50 total marbles. So the question is, how many white or blue marbles should she expect to find? White, 5, blue is 16. That is a total of 21 white or blue out of 50 total marbles. How do you build it up to 150? The scale factor is times 3, 63. Number 9, the answer is 32 made. So many ways to do this. I was helping some students on Friday during advisory, and they were doing mental math. So the 100% of the 40 free throws is 40 free throws. 10% is 4. So 80%, how do you build 10% to 80% times 8? 32. I saw one student in my first period class. He did 50% was 20. So he tacked on 10, 10, 10, 16 to 20 makes 32. That's one way to do mental math. However, some of you may not like mental math. No worries about that. So he made 80%, which is 80 out of 100, which simplified to 8 tenths. How do you build 10 to a 40 free throws? Scale factor times 4, and that's where you get 32. Many ways to do that. Number 10, Mr. Lamar coaches the golf team at Conrad Middle School. It has 18 sixth graders, 12 seventh graders, 10 eighth graders. That's a total of 40 members on the team. What percent of the golf team members are sixth graders? So 18 sixth graders out of 40. So many ways to do it. You could do mental math to figure this out. Many ways of doing it. Or can 40 go into 100? It does. You could do a scale factor at times 2.5 and come up with 45%. Or you can break this down, divide both numbers by 2, get 920. How do you build 20 to 100 times 5? 4,500 or 45%. I did see someone do mental math on this one. I was actually very, very proud of that person. He did 100% of 40 is 40. And then he did 10% is 4. 5% is 2. So how do you build 2 members to 18 members times 9? That's where you get 45%. Many ways of it. So tonight's homework is to finish your Unit 3 STAAR homework before you say, what was that? It's this one right here. And it says it's due May 10th, which is tomorrow, Thursday. So you have all the way up to 14 problems. If you do finish today's activity early, please get started on it. And then some of you are going to say, but I finished all of it already. I'm done with all of it. Well, good for you. Excellent job. You have no homework for the rest of the week. So for today's activity is, first thing is, can you tell me what a rational number is? We just talked about it in our in a warm-up. So a rational number, in case you forgot, is any number that can be written in a fraction or decimal form. Are these rational numbers? Is 4 a rational number? Yes. Can it be written in fraction form? 4 over 1. Is 50 hundredths a rational number? Yes, it is. It's 50 hundred or 1/2. Is 3300 repeating bar a rational number? Yes, it's 1/3. So all of these are rational numbers. So in this chart, in the beginning of the year, you were given different types of numbers and you were supposed to classify them. Remember the little baggies, the little gift bags we have on the wall. So for example, if I say -2, where would -2 go here? Is -2 a whole number? No, whole numbers are positive. Could be an integer because integers are positive and negative whole numbers. So it could be integer. But can it also be a rational number? Yes, it can. So it can go in more than one places. It can be an integer and a rational number because remember the baggie, this uh, this bag fits into the integer bag. So whole numbers are integers and whole numbers and integers are rational numbers. Next one. What happens if you get point -0.2? Where would that go? The whole number. Well, not really, because whole numbers have no decimal. Can it be integer? No, those are positive negative whole number. And then right here, it goes right here. Next one. What else? Let's do 6. Where would you put 6 in this chart? Well, 6 is a whole number. It's a number you can count with. Can 6 also be an integer? Yes, integers are positive negative whole numbers. And can it be a rational number? Yes, it can be, because can 6 be written in fraction or decimal form? 6 over 1 or 6.0. So the last thing is, before we begin our notes, is brainstorm everything you know about the coordinate plane. I was trying to help some students, and some students forgot how to graph coordinate plane. I would like you to take out your green paper, your green study guide, and I would like you to look at it. I think it's on the 3rd page. Think about it. So you may want to pause and let kids think about it. What is a coordinate plane? How brainstorm everything you know. So please pause. Welcome back. So in a coordinate plane, which axis do you begin with first? X or Y? Because I was helping someone during advisory and they could not remember where to start at. So first of all, you always start at the origin, right here. Origin is like the home base. So we start at 0. This is the x-axis. This is the y-axis. This is how I memorize it. I remember my teacher taught me this way. Think of the alphabet song. A, B, C, D, E, F, G, and M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. You start with the X, then Y. So you start with the 0, and you graph the numbers on the X number line, positive or negative. Then the second number tells you it's for the y-axis, up or down. So for example, please graph where would -2.5, -4 go on this? Would it be going in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? You do not need to know the quadrants. You just need to know how to graph it and read it. So please pause. Welcome back. So where did you put this? Where do you think it goes in? Hopefully you said it goes in quadrant 3. So starting at the origin, I go to -2.5, between -2 and -3, and -4 means I go down, so it goes right, 2, 3, 4, right here. This is where it goes. Next one, 7/2, comma, -2. So you may want to pause it and give students opportunity to find which quadrant this goes in. Welcome back. So 7/2. Can you turn this into a mixed number? How many 2's go into 7? About 3-ish. 3 and 1/2. If not, you could divide 7 divide 2. And you will also get that when you get rid of this remainder. 3.5, 3.5, 350%. Many ways to get this. So I go to 3.5 And -2 means I go down to -2 right there. And it is quadrant 4. So what you're going to do for the rest of the class is you are going to be ordering rational numbers. You are going to be doing multiple representation using independent and dependent and writing an equation from it in the form of y equal. And you are going to talk about points and so on. So first part is how do you order rational numbers? If I give you a list of fractions and decimals and put them in order, what are you going to do? So many ways to do it. Turn fractions to percent. Some people like turning fractions to percent because they like working out of 100. I do. Maybe you like working with decimals instead, into a hundredths place or a tenths place. Maybe you rather draw the fraction bars. Maybe you like estimating, because I actually had kids on Friday who were estimating, say, this is half, less than half, more than half. And then some people like doing least common denominator to write equivalent fraction. In case you forgot what least common denominator, you did learn it in 5th grade. For example, if I have the fractions 1/2, 3/5, and I don't know, 7/10, what denominator does 2, 5, and 10 share? Denominator. What denominator can I rewrite all of them into? How about 10? 10. Oh, sorry, 10. Can 2 go in 10 times 5 times 5, 5 tenths. Can 5 go in 10 times 2 times 2, 6 10. So we have 1/2 is 5/10, 3/5 is 6/10, 7/10. Now it's easy to compare it. So what do you like doing? Circle which method do you prefer? Do you like percents, decimal, fraction bars, estimate, I forgot to write estimate here, or least common denominator? Then what you're going to do is you're actually going to show the work. You literally will show me the work. I expect to see this tomorrow. Then you'll scan the QR code when you're done with all of these. So you will need a device. You will scan it. You don't have a device, ask someone to check with, and it will tell you the answer. Next part is you're going to answer A, B, C, and D. Can you look at this coordinate plane and write out the, God, this is so small. I'm so sorry about that, guys. Uh, yeah, so can you, can I see it? Can you write out the coordinate plane and fill out the table? And can you write it, decide if it's additive or multiplicative and what equation? Same as this. And then you have 2 practice questions. The teacher in the classroom does have the answer key, so he or she can check. You can check your work with them. When you're done with this activity, you will now start your STAAR review packet. All right. Good luck.